Well, let's welcome back. Everyone stand up again. We need a little bit of a stretch. Just welcome back our great leader here, great man of wisdom, Mr. John Miller.
Thank you. So, how was the lunch? Oh, no, we didn't have a lunch break, did we? Just checking to see if you're paying attention. I started out in the session before, talking about the NeoLife difference and how deep it is, how broad it is, how much it's not, just marketing slogans for us. It's the way we behave. Okay, it's right down to the roots of the company, to its origins, and then everything that's gone on since then. So I want to take you, again, this is another one of these requests where Louis wanted 60 plus years of experience crammed into just a few minutes. So I'm going to take you through a quick sort of wander through NeoLife history, how we got to where we are, how that drives raw material selection, how that drives us towards all this clinical evidence we have, and how we sort of manage to navigate the world out there and end up with products that really help people. Okay, they really help people. We know that they're going to help people because we know that when these things are absent or deficient in the body, that the body is somehow compromised. That's just it's the rules, right? It's just the way it is. Simple as water. If you don't get enough water, I have a bug. If you don't get enough water, you become compromised. You become dehydrated, right? And that's just a very simple way of looking at this idea that you need to have these things, and without them, there's some form of compromise. So those things have always guided our path, knowing that what we are going to deliver is going to provide benefit. But then we go the extra mile in saying just because we know that doesn't mean we don't have to prove it. Okay? So we tend to generate a lot of clinical evidence to support our products, the claims we make for our products. We're one of the most thoroughly researched product lines in the world, certainly probably in our channel, the most researched. There are other good companies out there doing good products, but they tend to take a different approach than we do. So I'm going to take you through this, a little presentation I put together here, and we'll see. This is called the NeoLife Story, Decades of Product Science Excellence. I'm going to stand over here again so that I can highlight some of these things. First of all, 1958. Okay, that's when the company was started, 1958. How many of you remember 1958? Not very many of you, okay? I remember 1958 very clearly because I remember when they rolled out the 1958 Chevy Impala, okay? That cool sort of back sculptured around that 3 tail lights, and didn't look anything like the 57. Didn't look anything like the 59 either, so either they thought it was a mistake, but I thought it was cool. But 1958 was a really strange period of time. There was, we were really young, okay? Really inexperienced, naive, would be a way to put it, relative to where we are today. Our understanding of nutrition and biochemistry back then was very rudimentary. They were still saying, just eat 3 square meals a day, okay? And you'll get it done. Well, we've subsequently found that that doesn't work. First of all, who's got square plates? Anybody got square plates? Okay. Me too. I have some square plates just so I can use that on my guests when they come over. I'm going to give you a square meal. It's the way I get into talking to them about the importance of diet, right? However you get there, it doesn't really matter. Just get there. So 1958 was really strange, but 1958 was really a sort of a hallmark year in the United States of America, maybe probably in the world, because also in 1958 this happened. Okay. Oh, nope. Oh, that did happen. 1958, minimum hourly wage was $1 an hour. Okay. And they were not paying me that much, so I'm going to file a lawsuit. There's no statute of limitations on Paperboy, is there? Come on. The average rent was $92 a month and gasoline was 25 cents a gallon. And they were making huge profits off it. Okay. The first Boeing 747 flight started. Hula hoops were invented in '58. Did you know that? Right? And the peace symbol was created in '58. One of the big trends was plastic furniture, because plastic was all the rage, right? It was all new stuff, right? Cost 4 cents to mail a first-class letter, and this was a state-of-the-art washing machine. You remember the wringer washer? This was super because you didn't have to turn the crank on the wringer. You could just feed it in there. Don't feed your fingers in there, though. It's going to eat you up. So that's quite stuff. And then there's this famous Ford's biggest seller that year was the Edsel, which was destined for a short life expectancy. Okay, so it was really weird. But here's the really big events that happened in '58 is this. Okay, two big events, NASA and NeoLife. Pioneers, okay? And surprisingly enough, I worked for both of them. Okay, back in the late '60s, I worked for NASA at Moffett Field working on guidance control systems for the Apollo Moon project. I was in the flight simulations department. I was going to the moon long before they went, but just never left Moffett Field. So to me, these are monumental things because both of them mark the beginning of a journey. Okay, both of them mark an exploration. They were exploring outer space, we were exploring inner space. Right down to the cellular level, okay? Is it a coincidence that both of those happened the same year? Or was it destined to happen? So let's take a look. Along the journey here, you know, from 1958 to today, we have this reputation for scientific leadership. We have unique products and technical innovations. I'll take you through some of those. We have a reputation for scientific excellence, right? Not only in the industry, but amongst researchers as well, amongst academia. That'd be universities and research organizations that are associated with education. We are published many leading scientific journals, and we have partnered with some of the greatest scientists and institutions in the world along the way. So here's how it goes. In decade one, we opened the company with the world's first, and possibly only, whole grain lipid and sterile derived dietary supplement. Okay, this was something that people just didn't do back then. They just didn't understand the relationship, but it was apparent from the research that had been done in the 1950s that there was a connection between the presence or absence of whole grains in the diet, in particular the whole grain lipids, and how well your body performed. In the clinical study hospital study that was done that became the genesis point for Trianin, they showed that when whole grain lipids were deficient from the diet, that energy production and things like that were compromised. They didn't have the technology that we have today to look deep inside the cell, but they could make some speculation from understanding how the body works, and they speculated that somehow the presence or absence of these whole grain lipids and sterols impacted how well our cells worked. And they were very insightful because now we know today, and have known for a long time, that is exactly true, that those lipids and sterols are used to build not only the structure of your cell, but the function of your cell. Not only how it's built, but how it acts, how it performs. So critical to that. But back then, they didn't know. But there was something that they realized. We were the first company to deliver that. That product resulted in this product, which was a children's version of Formula 4, Trianin, right? Had the same approach. Deliver these whole food, whole grain nutrients, but do it in a product directly for kids. That resulted later on in the formation of the generation of the product we know today, still as Liquivite. Though Liquivite has been improved, added to several times over all of those decades. We also developed this thing called protein instantizing. You know, protein was a big part of the business. If you saw that sign back there, let me back up here, right? See, it says, "Eat NeoLife protein." Okay, that's big message. That was an expensive sign for the company back in 1958. So that's a big message. So in that thing, we developed this idea of protein being more important than people thought, that there are good sources of protein and bad sources of protein. A lot of what was perceived to be the best sources of protein also had the highest levels of fat. So messaging from the medical community was, avoid fat. They had you don't eat eggs, they said for a while, and don't eat butter, eat margarine. Don't eat the natural thing, eat the synthetic thing. Like I say, they were very naive at the time. So we developed this protein instantizing process that took these otherwise insoluble proteins that we would extract from both dairy and plant sources and turned them into things that not only mixed in water, but ended up tasting great and being very smooth and stable, which was a brand new technology then. That protein instantizing process later led us to ProtoGuard process, which we still employ today, that protects the protein during manufacture. Proteins are very sensitive to heat and light and things like that. Even the speed at which the blender works determines the amount of friction that appears in the mix, and friction equals heat. Okay? So when we dial these things in, one of the great lengths we go to is just understanding how much friction the mixer actually puts into the protein. Most companies wouldn't even worry about it, wouldn't want to think about it, but we knew that heat degenerates protein, and what we're trying to deliver is the best possible protein, so we need to look at and account for all the things that we know might detract from it. So that's one. So heat, light, moisture all detract from that. So we control all of those in the mixing process. That enables us to not only identify the presence of amino acids in the product, but to stabilize them. Because when proteins denature, when they break down, it's the amino acids that start to break down. Protein is just amino acids. So it breaks down the protein, breaks the amino acids off from the protein structure, and then degrades the amino acid. So stabilizing the amino acids, not just making sure you're not overheating the protein, but stabilizing the amino acids is important. And then by doing that, we were able to show that we could maximize bioavailability of the amino acids. And protein's important. Putting it in your mouth doesn't mean it's going to get in your body. So making sure that you do everything you can to maximize its bioavailability, that it gets digested and absorbed and ends up in your body and breaks down and enters all of the amino acid pools is critical. So that was decade one, just a few little achievements. We were the first company to do this sort of thing, by the way, which is why we have such a head start. In decade two, this was probably, even though decade one was sort of getting things going, decade two, I think, was a real turning point for the company, because that's when Dr. Arthur First joined the company. Now, most of you probably know the Dr. First story, but for those that raised your hand, Dr. First was one of the preeminent cancer researchers and toxicologists of the last century. If you got him and his counterparts together, people of similar sort of impact in the world, and bought them lunch, you could probably sit them at a table for four. He was a driver of things. He was deep into the idea of what causes cancer, to the point that in the early 1950s, he actually came to Stanford University and was given a bunch of money by the American Cancer Society and other donors and the university, and created Stanford's first chemotherapy laboratory. He came up with the concepts of chemotherapy. He took the approach he took is, if you understand toxins, if you understand what causes cancer, then you can find out how to inhibit the cause. If you just go after the cancer without knowing what's causing it, you can't really stop it from happening. Okay? So he took that approach, and over the years did some amazing things. He went around in the middle 1950s as the top cancer researcher at Stanford School of Medicine and a spokesperson for the American Cancer Society, going around to newspapers and big events and talking about his discoveries. He discovered the idea of chemotherapy, meaning that by understanding what causes cancer cells to occur, he found out how to fight them. So he would give them a a chemotherapeutic agent, and that agent would attack and kill the cancer cells. Later on, he was involved in the discovery of the idea that, cells are pretty smart, even cancer cells, and they will adapt. So they become resistant to one form of chemotherapy. So he developed the idea of using what he called a chemotherapeutic cocktail, 2 or 3 or 4 together, to keep the cells from being able to dodge that bullet, right? When they dodge one bullet, they dodge right in front of another one. So, and that's still the way they do it today. If you're unlucky enough to have that happen, where you need chemotherapy, or you know somebody it is, probably they're getting a few chemotherapeutic agents together because that's the most successful way to treat it when it gets that bad. And that would come right back to Dr. First. So at some point, though, late in his career, late at Stanford, about 1959, 1960, he decided that, fighting cancer was a good idea, but he wanted to prevent it. He felt that he had learned enough about what causes cancer that he could work on the idea of prevention. So he left Stanford and went to the University of San Francisco and formed the Institute for Biochemical Research, which was an institute that he put together. I think he funded it initially, but got a lot of contributors. And put that together and started this idea of looking at ways to prevent cancer. And along the way, in about, I would say, late 1960s, he started to get attention because he was out there talking about preventing cancer and using nutrients to stop cancer and so on and so forth. And he got a lot of attention from people who wanted to say that wasn't true. He was fighting a headwind. And, we deal with those all the time, even today. Was fighting a headwind and started looking around for people of like mind. And it took him a few years, but in about the middle 1970s, he encountered a fellow named Don Pickett, who had a company called NeoLife, okay? And they sort of came together at one of these health fair type things. And he got to talking to Don, and Don talking to him, and they became friends. And the more that they became friends, the more enamored Dr. First became with Don Pickett and NeoLife's approach to the idea of maximizing health. Oh, thank you. Vodka. I hope not.
90 proof.
90 proof vodka. Vodka's usually only 80 proof, isn't it? Thank you. So anyway, to make a long story short, because it's a long story, they got together and they realized that they had this common goal and challenge in mind, and that is to maximize health and thus minimize disease by focusing on this idea of nutrition, which was right where Dr. First wanted to be. So he came on board. First thing he did was introduce double amino acid chelation, which is a way he found that minerals are not easily absorbed in your body. They tend to want to react with everything when they're converted to their elemental forms. Excuse me, I came armed. I have an all-C, which will solve this. This is really good. If you ever get speaker voice, I'll see. Okay. Works for me every time. So anyway, already sound better, huh? Not so scratchy. Anyway, he brought in this idea he discovered this idea that if you treat minerals in a certain way, that you can get past the fact that they want to react with everything. Sodium, for example, wants to react with chloride and form sodium chloride. You don't see any free sodium around anywhere. Same thing with calcium. You don't find elemental calcium around anywhere. It's always reacted to something. Calcium carbonate, calcium citrate, calcium whatever. So he found, though, that when your body digests that and releases that elemental calcium or zinc or iron or whatever, it wants to react with things that are in your digestive tract and form something else, and the majority of that won't get absorbed. If you know how to make soap, you understand that if you take a mineral like calcium and you put it together with a fat like tallow and a little bit of this and that, you can make bar soap, right? Very stable stuff. Well, your body won't absorb that. You've lost the calcium. It got bound to the fat and will get carried out. So he found that if you just treat that ionized mineral with a couple of amino acids, you can make it very bioavailable, which he did. You know, it's dry at 6,000 feet, isn't it? I just came from Texas a couple of days ago. Relative humidity was like 80. Relative humidity here is like 8. So let me move on. Anyway, soon they created the Scientific Advisory Board and turned the destiny of the company over to a group of scientists called the Scientific Advisory Board. I was lucky enough to be one of the first members that Dr. First brought onto the team, myself and Dr. Hooper and Dr. Ken Hirsch. The old-timers will remember Dr. Hirsch, but the more recent ones won't. Good guy. Anyway, so they formed that, and the future of the company changed forever. At the same time, they introduced Neoplex Concentrate, this idea that whole citrus extracts belong with vitamin C, because nowhere in nature do you find vitamin C without them. So why shouldn't they be there in your supplement too, just like they are in food? Yes. Lipotropic adjunct for lipid mobilization. We know that your bloodstream is mostly water, so when you get fat in it, what holds the fat in there? You've got to have these emulsifiers, these lipotropic factors. And the presence or absence of those determines how well those fats, how stable those fats are in your bloodstream, and if fat starts falling out of solution in your bloodstream, your probability of plaque formation increases rather dramatically. So maximizing your presence of lipotropic factors is good. So that was about lipid mobilization when you're burning fat. If you've stored some fat here and you're going to go burn it for energy, you've got to get it out of here into your bloodstream, transported to where it needs to be utilized, right? Into the liver or wherever it's going. So it's got to be in the bloodstream for a while. So if you're losing weight, this is an important thing to consider, is maximizing your fat transport system, okay? Oop. I went backwards, huh? Fat thumbs, I tell you. We also introduced digestive enzyme supplementation back there. Now this idea and the homocysteine idea are pretty de rigueur today, meaning that they're pretty much considered the leading edge of science. We're talking about the 60s and 70s now. So, you know, we have a 50-year head start on a lot of this. Decade 3, we developed what we call an artificial stomach. Again, it's one thing to take something. It's another thing to know that it's going to be digested. It's one thing to make a tablet or a capsule. It's another thing to know that it's going to get digested and broken down and that nutrients that are in there are going to be available. Way back there, one of the things that we did way before anybody else was thinking about it is we said, if we're going to make a tablet, we want to make sure that that tablet is going to be easily digested. So how do we do that? Well, we created an artificial stomach. In the laboratory, we built this laboratory apparatus that mimicked the stomach. It had a stomach acid medium in the test tube, in the beaker. And we had a thing that went up and down that mimicked peristalsis, you know, the sort of pumping of your gastrointestinal tract. We had other things that measured temperature to keep it so that the fluid that was in there was the same temperature as the fluid would be in your stomach. I mean, this is way back there, and so we do much more now. But back then, this was state of the art. And you know what we found is that there were a lot of products out on the marketplace that just went clink the next day. You know what clink the next day means is? Okay. In the porcelain, clink. So because they would press them so hard, because then they wouldn't break up in the bottle, that they wouldn't break down. They'd become like stones. Okay. So we had always known that compression, as we call it, was a factor in this. So we'd always focused on compression, but now we developed a tool that enabled us to dial in the level of compression relative to how quickly the thing will disintegrate once it re-arrives in your stomach. Okay. This was really state-of-the-science stuff. And like I say, we do much more than that today. But by doing that, we can control disintegration time, we can control dispersion time, and we can control, or certainly dramatically influence, bioavailability. So we did that way, way back there. That same technology allowed us to do targeted delivery technology, which we do now. Not only do we develop a product that works in your stomach, we have dialed it in so we can deliver it right to a certain spot in your intestine and release it there. Okay. there's things that you can break down in the stomach and digest and expose. For example, garlic would be a problem or acidophilus would be a problem if it didn't survive stomach acid. So we were able to develop technologies that some things get into the stomach, break down quickly. Other things get into the stomach, don't break down quickly, actually pass through, then don't break down until they arrive in the intestinal tract, which is where they're needed, okay? Because the hydrochloric acid in the stomach represents a challenge. So we developed targeted delivery technology that enables us to deliver certain nutrients directly into certain portions of the gastrointestinal tract to the exact point that they're needed, okay? For acidophilus as an example, you don't want it breaking down in the stomach. You actually don't want it breaking down early in the small intestine either. You want to wait till it gets in there a little ways. But by understanding the pH, the relative acidity or alkalinity of the middle of the intestinal tract, small intestinal tract, you can actually devise a mechanism or a coating, if you will, that protects that ingredient until it hits that particular pH range and then boom, disintegrates rapidly. And that's just a small, not even close to how complicated it is. So we developed this. We developed out of this by learning about disintegration. We found that we could control disintegration. So threshold control is more than just sustained release. It's actually controlled disintegration that establishes a threshold of a nutrient where we can spread the delivery of a nutrient, a water-soluble nutrient like vitamin C or B vitamins, over a 6 to 12-hour window, okay? Which is important because B vitamins, water-soluble nutrients, go through your body pretty quickly, and the longer you can keep them present, the more you can control the threshold of their availability, the better off you are. So that's one of the technologies that comes from knowing not only how to make a product that breaks down quickly or one that doesn't break down at all, but how to control the breakdown of a product once it's in the body. We also did Texas A&M study there. This was the study where we validated the original trianin study that showed that when trianin grains are present in the body, nutrient utilization efficiency is improved, and all nutrients are utilized in the cell. There's no other place to utilize them. So it actually substantiated that trianin has the ability to improve how cells work, okay? Moving right along, in decade 4, in the 88 to 97, we introduced carotenoid complex. Now, we were actually deep into researching carotenoids for years before we brought this product to market. And I'm not going to tell you the whole story. It takes me an hour just to talk about this product and do a thorough job. But we had known, it had been shown that that dietary carotenoids, there's an inverse relationship between carotenoids and life expectancy and disease risk and things like that. When you look at it, those people who eat the most carotenoid-rich fruits and vegetables tend to live longer and have the fewest diseases. When we look at it's called epidemiology, if you take a look at 1 million people and you have data on that 1 million people, and you look at them over decades and you watch who dies and who doesn't, and what they eat and what they don't eat, and where they live and where they don't live, and what they're exposed to, you can begin to understand what's driving the disease states in them. What is the problem? By doing that sort of work, we saw that people who eat the most fruits and vegetables of color tended to live the longest and have the fewest diseases. Particularly those who had the highest carotenoid content in their diet tended to live the longest and have the fewest diseases. And then we looked at the USDA data about the presence of carotenoids in the diet, and it was apparent that the mass of the population was not getting enough of these things. They were pretty much deficient, okay? The reason is that in order to get to this carotenoid-rich sort of base diet, you had to at least eat 5 to 9 servings of fruits and vegetables every day. And the average fruit and vegetable consumption in America at the time was something like 2. And it's another one of those situations where if you're not getting enough of something that's vital, somehow that's going to compromise your body. It's going to result in a problem. And we quickly found that it was a driver of not a specific disease, but all diseases, and a driver of aging. Those people who had the most of these lived the longest, had that longest lifespan, and had the fewest diseases. 2 things you want to try for, okay? So, and then we went, the research we were doing on this was very new at the time. We were the only company that was doing this based on food. There was a lot of pharmaceutical companies out there based on synthetics. You know, Hoffman LaRoche had synthetic beta-carotene that if you take your 50 milligram tablet, you're going to do this or that or the other thing. Turned out to be a problem. That's why, you know, one of those studies that said carotenoids cause cancer, no. Big doses of synthetic beta-carotene cause cancer in smokers. Never was any data that showed that a carotenoid-rich diet caused cancer. Matter of fact, quite the opposite. Carotenoid-rich diets tend to prevent cancer. So anyway, we were doing that research. We got did a bioavailability study. We came up with a product, knew what was in it, fed it to people, checked that it got into their bloodstream. Rocket science at the time, okay? No one had ever done anything like that, specifically with whole food-based nutrients, with pharmaceuticals, maybe with one thing like synthetic beta-carotene, but no one had done it on a broad spectrum like we did. That got so much attention, we got invited by the New York Academy of Sciences to present the data at a meeting of carotenoids and cancer, and you can still find that publication online. And in that meeting there were a group of researchers that were there from the U.S. Department of Agriculture, and after they saw our data, they approached us and asked if we would mind if they did some research with our product, because they wanted to be able to use something that was standardized like ours was to back into recommendations of how much carotenoids people needed. And we said, sure, we're good with that. So we came and had a bunch of discussions and made placebos and did all sorts of stuff for them. And then they came in, and the first thing they did was reprove bioavailability, which was good. They showed that, just like we did, that they were bioavailable. It was not a question, but it's always good to have duplicate data from two different sources. They went on to show that when carotenoids from our product were in your bloodstream, it reduced markers of oxidation in the blood. That's important because oxidation of LDL cholesterol is a primary pathway towards the formation of plaque in your arteries. Okay. They showed that it was reduced oxidation levels on the cells because oxidation events on cells, very important. That's a pathway towards cancer. And they showed that it has the ability to promote immune status in two very important ways. Okay? Lymphocyte proliferative responsiveness, how many warriors you can deliver to the site of need, and natural killer cells, how many of those big bad anti-cancer guys you can deliver. Okay? And they proved beyond a doubt. They went around the world presenting that data and publishing it in the American Journal of Clinical Nutrition and a bunch of others. Again, if you guys all know about carotenoidcomplex.com, that website? You sure you do? Okay. You ever visit it? Okay, don't forget. I've found distributors who don't know about that site. Okay, and everything I just told you about and much more, all of the research is there, all the USDA stuff, all of the bioavailability data, et cetera, et cetera, et cetera. Anyway, out of that came flavonoid complex and cruciferous plus. Again, this idea of whole food nutrition. Okay, flavonoids are the water-soluble components of carotenoids, and cruciferous compounds are, bioactives that function in the body as cell protectors. They protect your cells by actually binding to the membrane. They also upregulate, that's increase the production of the cell's own natural antioxidant disease prevention system called phase 2 enzymes. That'd probably be the simple way to say it. Superoxide dismutase, quinone reductase. They've got all these wonderful big names. At that same time, we were the founding sponsor of this group here called FENREG. FENREG is the Plant Polyphenol Human Research Interest Group. It went from us starting that thing where there were maybe a dozen people in our group back then to now when they do their meetings annually, we do thousands of people in the room. And we're still the primary sponsor of the event. We developed gel guard technology. That came out of our artificial stomach thing, again, knowing how to get things through the stomach acid, but deliver them to the site where they're needed. That gel guard technology is pretty cool because what it does is we mix the stuff up in the presence, mix the acidophilus up in the presence of naturally occurring carbohydrates. And then when the gelatin shell breaks down, the acid actually turns the carbohydrate into a gel, and it carries it all the way through into the intestinal tract where the gel dissolves and releases the acidophilus. Tricky stuff. very high tech. And then we also brought to market VitaGuard, the first whole food antioxidant supplement for kids that was based on all of this. Okay? In VitaGuard, you find carotenoids and flavonoids and all sorts of stuff. Oh, yeah. So all of that in just a short period of time. In decade 5, 1998 to 2007, we developed glycemic response control technology. For those of you who don't know what that is, it's being able to manage how much and how quickly blood glucose enters your bloodstream. Glucose is your partner and your enemy. You need glucose. You know, we are glucose-burning machines, but you just don't need too much of it. Too much of it can be a problem. It actually tends to be corrosive and erosive and an oxidizing and inflammatory factor that breaks down peripheral circulation, which is why people who have diabetes often are confronted with a loss of circulation at their extremities, because it breaks down the little veins and arteries when they get way out to the end there of your fingertip. You know, there's nowhere in your body you can't put a pin and find some blood, thankfully. But it tends to be destructive to that. So we started thinking about, okay, what happens? People sit down to the average American breakfast, right? A bowl of cereal, a glass of orange juice, and a piece of toast. And it's all sugar. So you get these big glucose spikes coming out of that. So we said, yeah, that's not good. So then we looked at some of the weight loss programs that were on the market at the same time, meal replacements, and guess what? Sugar. So we said the problem here is that when you do this, you create a great big glucose spike, you force your body to generate an insulin spike. Your body is paranoid of glucose, so it overreacts and puts out more insulin than glucose. So the glucose goes from being way too much, hyperglycemic, to way too little, hypoglycemic. Okay? Not only do you not, now you don't have enough glucose to keep you healthy and alert, you have excess circulating insulin, which is not a good thing either. So we quickly found that by just controlling the relationship between protein, fats, and carbohydrates, and doing it in a unique way, that we could actually manage that so that if you had one of our protein drinks in the morning, unlike some of the others that were out there, that you could consume that and you would not get a glucose spike, and therefore would not need to produce excess insulin, and you would end up with a prolonged energy curve. Because when you go from hyperglycemia to hypoglycemia, your body says, oh, hypoglycemia is a bad thing, feed me. Right? And it's on about a 2-hour cycle. Okay? So, you know Dr. Pepper, right? Okay? Dr. Pepper was 10, 2, and 4. Remember the clock that used to be, you remember their clock logo? 10, 2, and 4? That's because they know you had breakfast in the morning, and by 10, that 2-hour cycle, you were going to want something more so you could have the friendly pepper upper, which was sugar and caffeine, right? And then you go to lunch at 12, and then by 2, you need another friendly pepper upper, and by 4, you need another friendly pepper upper. They were actually aware of the glucose cycle, glucose-insulin cycle, and that became part of their rationale. It was also the rationale for the candy bar companies for a while, who wanted to sell you a candy bar to get you home. The fact that you had, from work, right, the fact that you had a 2,000-calorie lunch, they're saying you still need more because, and the reason is because the lunch made a big glucose spike, and by the time you're ready to go home, you're hypoglycemic, even though you had this huge caloric load for lunchtime. It's called the glycemic roller coaster. Millions and millions and millions of people live on it every day, and it's more scary than anything you'll encounter at Great America. Because the crash is really severe. So we also introduced Salmon Oil Plus, standardized amounts of all 8 omega-3 fatty acids. There are 8 omega-3 fatty acids. There are 8 omega-3 fatty acids involved in human nutrition. And you know, we know the process. We knew about it years ago before we brought this product out. We could see it in salmon oil we had at the time. We just didn't have the technology to standardize it so we could identify and make sure all 8 of them were there in certain levels every time. We subsequently developed that technology here with our ultra-high potency omega-3 technology, molecular differentiation process, unique to us, where we can take that sort of marine lipid, if you will, the raw salmon oil, we can identify the molecules we want to keep and the molecules we want to get rid of. So we weren't too interested in keeping any of the toxins the salmon might have, or certain elements of color or odor that play no role dietarily. They're just part of the... And we were able to then standardize all 8 of those. And through this process, we screened for more than 200 contaminants along the way. When we differentiate molecules, we can tell that that's a toxic molecule, a toxin, by looking at the molecular structure. So by differentiation, we throw that out. We only keep what we want to keep and eliminate the things that we don't want. I recommend ALSI. We went on from there and did our salmon oil human clinical trials. You know, for those of you who don't know, really, really important studies. These are, again, nobody in all of the industry was doing this sort of work that we were doing, just because it's hard and it's expensive. And, you know, you only do this sort of work if you're actually concerned about what's being delivered to your product. We have this belief system that you are all family members, right? And so we treat you like family members, and we, a long time ago, decided that oops is a 4-letter word that would never be part of our language, right? So when we do this, how sure do you have to be? How sure do I have to be to give it to my child or my grandchild? Pretty sure. So we go to great lengths. So this sort of work we were doing here, we did a human clinical trial. It's called an intervention trial because that's the way the intervention trial is, where you get a group of people and you say, don't do anything different, keep living your life just the way you are, but take this, okay? Because that's the way these things enter the population, right? That's the way they get into the people, continue living their lives and start taking the product. It's called an intervention trial. So in that, we did that, and the results were tremendous. Again, we showed rapid bioavailability. We showed that these things are bioavailable almost instantaneously, meaning that you take them and they're going to appear in your bloodstream, start to appear within hours in your bloodstream. And that when they're there, they'll get into the bloodstream and they'll immediately start changing the inflammatory index of your cell membranes, of your red blood cells. What they do is it will kick out inflammatory fats, arachidonic acid is an example, and replace it with anti-inflammatory fats. Recreate that balance we're talking about, create that balance in the bloodstream, or in the red blood cells. So we proved bioavailability, lowering triglycerides, improved in omega-3 index, the relationship between omega-3 and omega-6 index, and lowered the inflammatory index. These were big, big, big things back then. They're still big things today, but no one had ever done this kind of research. So our human clinical trial got published. We got invited to have it published in the Journal of the American College of Nutrition. And then it went on for a portion of that. We did some follow-up research with a fellow named Karsten Gronert from UC Berkeley. He was one of the guys that actually figured out how omega-3 fatty acids quench inflammation. Not that they do, I mean, we knew they did, but how do they do it? What is the mechanism of action? And which ones of the 8s? Are they all involved in that, or are some of them involved in other things? So as we began to investigate that with him, we proved that when he was at Harvard, he had proved that omega-3 fatty acids quench inflammation through the production of a biological compound your body makes called resolvins. They called it resolvins because they resolve inflammation. So he showed that the body has the ability to do that. So in our particular case, he showed that when these people that were taking Salmon Oil Plus had a tremendously increased capacity to produce these resolvins and thus quench inflammation. It went back to what I was telling you about dislodging inflammatory fats from cell membranes and that sort of stuff. That's part of the process. But what was even more compelling about that is we learned that healing never fully occurs as long as there's inflammation still lingering. So when you cut yourself, you get a little localized inflammation around the cut, right? It's your body's immune system creating a barrier against the intrusion of germs and things like that. If you get a serious set of damage, then you're going to have a serious amount of inflammatory overload. The other way to get an inflammatory overload is to just have too much omega-6 and not enough omega-3. So he found that two things happened. If you have an overload, one way or the other of these things, healing is inhibited. You can't fully heal as long as inflammation persists. So even a low-grade chronic inflammation that many people have, driven by diet, okay, functions to inhibit natural healing processes in the body. I felt the same way this morning. I think I sounded like that when I got up, too. Just kidding. So they found that healing can't really exist, full healing can't exist as long as inflammation persists, and that you need resolvents to cause that to happen. And he and Dr. Karugi showed that salmon oil plus boosts resolvents and thus promotes healing as well as the inhibiting or correcting the inflammation. That became so, that was published in the Journal of Translational Medicine. That means taking science and translating it into medical applications. So we got that published there. And it was so compelling that the research that we did here ended up being cited in the Journal of the the New England Journal of Medicine, thinking of a different study, New England Journal of Medicine, as a reason why everybody should take an omega-3 supplement every day. And in the study that they cited, the evidence they cited, ours was the only human data. Okay? It's because people don't do human data. It's expensive. It's complicated. It's time-consuming. But if you want to know how it's going to work in humans, you probably should try it in humans. So moving right along, in decade 6, we introduced Trey. Trey is, for those of you who don't know, it's more than just a nice little beverage. It is a great beverage, by the way. But it is power-packed full of water-soluble antioxidants and anti-inflammatory compounds called polyphenols. It's also got a lot of things like alpha-lipoic acid and resveratrol and things like that in it that are all primary protectors of how your system works. We call it a potent shot of wellness. I think that was Josh Clark's language, so I'll give him credit. And it really is. It's a potent shot of wellness. I love that stuff. The problem I have with it is I'll have it in the refrigerator when my grandkids come by. They think it's just, I'll just pour myself a glass. You know, can I take one of these home? So it disappears as quick as I can get it in the house. We also did a NeoLife Shake human clinical trial. If human clinical trials seem to come up constantly in our program here, it's because we do them all the time. Who knew you needed to do a clinical trial on a protein shake? We needed to know how it worked. We wanted to make sure that, you know, it was going to not only cause weight loss, but how? How does it do that? And how do we maximize that benefit? And does it do it all the same for everybody? How do you know that? So we started doing human clinical trials against a free living population again, people right out in the real world, and brought them in, took baseline stuff, body measurements, what we call anthropometrics, right? It's all how you measure your thighs and your ankles and your hips and your arms and your waist and everything else. And you put all of that in there along with blood data and everything else you can think of. And then along the way in the study, you stop and collect that data again. And then at the end of the study, you collect it again. And then you compare the starting data to the ending data. And we saw amazing things. Not only did people lose weight, they lost body mass. Now, I don't know about you, but most of the people I know would rather look better than they worry about the scale. If I look better, the scale can say the same thing. Or the scale can say I lost 2 pounds, but if my friends say, hey, you look like you lost 10 pounds or 20 pounds, I'm good with that, right? So this idea that it can change your physical appearance was important. Diet is often about how I feel about myself. That keeps me motivated, as well as what's it doing to my health. So in this particular case, we showed these. improvements in anthropometrics, smaller thighs, smaller arms here, smaller waist circumference on the participants in the trial. Saw a reduction in body mass index, then saw improvements in cardiovascular disease risk factors, improved the cholesterol, lowered LDL, boosted HDL, improved the HDL-LDL ratio, improved the HDL to total cholesterol ratio. All of these things being very positive indicators that your heart health is being improved, your heart disease risk factors are being diminished. And if you're coming off of weight, if you're probably got in your mind someplace that, you know, if I'm overweight, it's hard on my heart, which it is, by the way. So, coming right along, this study, whoop, there I go, leaping back and forth, published in the American College of Nutrition right there. We introduced CoQ10. I just told you about CoQ10, so I'm not going to go back through that, but it's really important product. We introduced glucose balance here in the 2008 to 2017. Again, the more and more you hear about glucose, the more and more you're going to learn. One of the things that we have found out is diabetes is only one of the risk factors of elevated blood glucose. Okay? Kidney failure, liver failure, non-alcoholic fatty liver disease, and a number of other things are indicators or are risk factors for elevated blood glucose. So when people take it to lower their blood glucose, it's fine if they're taking it because they're, you know, worried about diabetes or pre-diabetes. That's a good thing. But there's much more benefit to this product than just that. I just use it as a dietary supplement. My glucose levels are not bad. I can tell you they're in my smartphone. Okay, I've been tracking them for years. Everybody know their glucose levels? Raise your hand if you know your glucose. Wow. I'm a data guy. You should know your data. Okay? Okay, you know how tall you are? Yeah, okay. You know how much you weigh? Okay. That's interesting, but not important. Okay. Do you know what your blood pressure is, your average blood pressure? Resting heart rate? Blood glucose? I know all of that. I have all my triglyceride data. You know, I can access everything that's gone on because I'm a data guy. This watch here feeds data to my smartphone that uploads to my computer at home automatically because I'm a data guy. Because I need to know, I do it, I'm not really much at risk of anything, it turns out, but I do it because I think it's important that we all know that. You should know your numbers. You don't need to test your blood glucose every day. $29. You go down to CVS, you buy a glucometer, okay? $29. You can know your blood glucose. Why not? No one's got an answer for that, huh? Okay. I suggest that you do. Not to worry about it, but why not know what your blood glucose is? Here's another thing to consider. Wherever you are now, it's good to have data. So wherever you end up, they can look back and say, this is how I was then. Because often finding out what's wrong today is looking at what's changed since yesterday. Okay? Think about it, folks. You can help other people get that too. They should know that. Anyway, this is a great product. I'll get off my high horse now. I'll get back on another horse. Nutrients Organic, I'm not going to take you through this. This is the first totally organically certified skincare product in this part of the world anyway. And I don't know about you, but I always did like Nutrients. I was always a collagen cream guy, okay? But I really like these products too, because the thing about collagen cream is that it had collagen in it, and that collagen came from pork, and it was sort of the same sort of collagen that they used in burn patients and things like that. But it was basically a topical thing. It wasn't really dealing with what my skin needed entirely. So when we brought this product out, we intentionally avoided using any animal tissue in any of these products. You can get organic animal tissue, organically certified animal tissue, but we intentionally left that out because we wanted to go down this path of just relying entirely on organic, plant-derived, seed-derived sources. really, really good product. I'm not going to go into it or I'll be up here for another hour. In the next decade, this current decade, 7th decade, we did the glucose balance clinical trials. Again, because we wanted to know what happened for people. And these are ongoing. We're still doing these trials, so there'll be more information coming out. But if you look here, you can see this was a human clinical trial. This is blood glucose levels, right, over time and in minutes. And you can see that right there. This is the green one is the glucose balance. People who had glucose balance. This is their blood glucose level, and the orange one is the placebo. So as we compared people, we could see that somehow our product caused a reduction in blood glucose entering the bloodstream compared to the placebo, which was just nothing. Okay, the reason we want to do that is the evidence we had from raw materials and other sourcing issues said that that was going to be working that way, and we wanted to prove it. Okay, and we did. Important indications. I took you through vitamin D already, so I won't again. And this product continues to be one that I think you should pay attention to. There's a growing marketplace out there for vegans, but as I pointed out in my first session, they're at risk of a lot of things. One of the things they're at risk of is not getting enough protein. So this is 5 sources, these whole plant sources here. Complete amino acid profile and rich in branched chain amino acids. It's exactly what other products don't do. Okay, they may be vegan, but they're not doing this. Okay, important to talk to people. So, like I say, we have a rich scientific heritage. This is just some of the research organizations and entities that we have partnered with over the years that have either done work on our products individually or with us in conjunction, where things have gone. But we currently have a project going on at the Linus Pauling Institute right now. And hello. Oh, these are just some of the journals that this stuff has been published in. What are you smirking about?
I said, tell us more.
Tell you more. Okay. These are just some of the journals that they've been published in. That's the New York Academy of Science annuals, Carotenoids and Human Health. And about halfway through that publication, you'll find the carotenoid complex data from Dr. Kruge and Dr. Hooper. And anyway, this is the one where we did the bioavailability studies and the New England Journal of Medicine we already talked about. But, you know, just as an aside, just as a stopping point here, this is not normal in our industry, okay? This is not normal in our industry to have that much clinical evidence from a lot of it from third parties, powerful third parties, published in peer-reviewed scientific journals. The process of peer review is a bunch of people get together and try to figure out why your stuff shouldn't be published in their journal. Find some flaw, some fatality, some miscalculation, some bias in it. And only after it passes that gauntlet do they publish it. So it's not normal for people, companies in our industry to have this level of stuff, okay? And it's not like we have one, we've got dozens of them. So this is the Scientific Advisory Board. You know, we're still very active today. I just said we have a project going on up at Linus Pauling Institute with our Product Science and Technology group, and Dr. Clayton is leading the charge there, and some work that we're doing. I'm not telling you more about that. Not about that. No, we'd like to, you know, it would take me days to tell you about all the things that we're involved in, okay? A lot of it would be boring, and you would think, well, why are you doing that? Why do you care about that? Why do you care about friction coefficients in blended materials? Or because we do. But there's a lot of stuff going on all the time. We just had a meeting yesterday. Kendra was in that meeting. Took the Product Science and Technology group and set out our priorities and goals for the next 3 years. And SAB's priorities and goals actually go beyond that. We have a 5-year plan. So I'm going to talk you through the NeoLife difference in ingredient sourcing. You know, nature plays a big role in our deal. We believe in following nature's blueprint. Nature and science make wonderful partners as you're going to try to figure things out. So I'm going to tell you a little bit about nature. Nature and natural. You would think they're closely related, but that's not true. Natural does not necessarily mean it's good for you. It only means that it exists on this planet. There are a lot of natural things that you don't care about. This is an example I like to give here is EU approval sought for antioxidant wood chai. A Russian firm has applied for a novel ingredient for wood extract, which antioxidants, anti-inflammatory, and cardiovascular benefit. If you're a beaver, maybe, okay? But why wood when you've got food? I don't get it. Why wood? Because what else do you do with sawdust? You know, you turn that waste product that's probably an environmental toxin into a dietary supplement. So natural doesn't mean anything. This is natural. They would get to call that natural because it was natural wood. It's not synthetic wood, it's natural wood. Same thing with organic. Organic doesn't really mean anything. Organic standards, other than the way we certified ours, but organic doesn't necessarily mean much of anything, and here's why. In the United States of America, right, this is from the Washington Post, an audit of the organic program. The Washington Post published a story last month describing how federal organic standards have been relaxed as a result of decisions by program officials and an advisory board that had approved a growing list of non-organic ingredients. Whoa, wait a minute. How can an organic certifying body approve a growing list of non-organic ingredients? There's an oxymoron in there someplace, and he's probably in government. Crazy. So also, certifiers often set their own criteria for determining what products earn the federal organic label, leading some producers to shop around for certifiers. So the third martini at lunch with Willie. Willie, you know, now that we got you here, Willie, how would you like to sign our certificate? Okay. Not that extreme, but how can you shop around for a different certification? One of the reasons we've always struggled with this idea of organic is it's not a scientific standard. It's somebody's opinion. Okay? And our opinion, frankly, is the only opinion we want to listen to. So anyway, so natural means nothing. These are all ingredients that our competitors use. This is a source of carotenoids called Dunaliella salina. There's a company that starts with S that uses that in their products a lot. This is another one called Blakeslea trispora. There's a company with a big P that uses that in their products. And these are all natural things. So they're natural sources of these things, but they've never been in the human food chain. So that's why we have this idea, NeoLife Difference is human natural. When we say things are naturally sourced, we mean it's naturally sourced from things that are natural to you, right? Not things that are natural to a horse or a beaver or a dog or an insect, things that are natural to you. They're the things that were put before us in our food supply. That's where we get our raw materials. That's where we do our work, human natural nutrition. So examples here, this is the African potato, which, by the way, isn't a potato, but there's a company out there that was selling this as a source of lipids and sterols. For the same reason, they were trying to say because it's good for your cells. They had no evidence. Had no evidence, but this is what we use, and we have evidence, right? Here's another one, cell-protecting carotenoids. These are those two sources, Dunaliella salina, which is basically a form of pond scum, and Blakeslea trispora, which is an asexual microorganism. Doesn't sound very nutritious to me. That's where they get carotenoids. This is where we get ours, right? Same thing with fish. So you can get, you can get algal omega-3s, and you can get, the leftovers from making cat food, things like that. There used to be a lot of fish emulsions on the fertilizer market. You can't find them today. I think it's because they've turned them into dietary supplements for humans. But ours is this, right? We'd like to stay right where nature intended. We also do a lot of work to fight GMOs. We have known for a long time. Dr. First was at a meeting in the early 1980s in Washington, D.C., and came back from that meeting, had a special scientific advisory board meeting, and said he went back there to see some evidence on the type of tomato that was genetically engineered to have a thick skin so that it could be harvested by machines. Tomatoes don't lend themselves to machine harvest very well. The best tasting ones tend to be thin-skinned and juicy. So the machines tend to turn them into tomato paste rather than tomatoes. So he came back and warned us. I went to that thing and, I saw this pretty cool technology and everything. He said, but there's a problem. And he said, when I asked them, what did it do to the nutrient content of the tomato? He says they had never even looked at it and didn't really much care. Okay? So he said, that's a bad sign. And industry has gone down that path ever since. That was the middle 1980s. Industry has gone down that path. So we have been on the GMO alert for decades. This is not something we adopted last year or last month or even this century. It's been well in our DNA for a long time. Today, originally genetic modification was easy because you could see it very easily. You could just run a genetic screen and you could see, oh, look at there's marigold genes. What are they doing in the middle of that soybean? Okay, easy to identify. But now they've gotten a little more sophisticated since they've introduced this CRISPR, this gene editing thing. Okay, they just go in and cut out a piece and put in a piece. And you can't tell where that other piece came from. But that's not the end of the story. They're even getting more sophisticated now. If you understand genetics, you have DNA, right? And you've got 4 things that make up the genetic code, 4 base pairs, they call them, 4 bases. And now they go in there and they just start flipping switches. They just turn things on and off so that when the genetic code is read, when your system reads it, when it actually uses the code to produce something, it skips over the bad things and only does the good things that they want. The problem with that is often the things they're leaving out are things that are fundamental to our bodies. They're great for the genetically modified salmon that goes from, a salmon egg to a full-grown salmon in 9 months as opposed to 36 months, or a calf that goes from being a baby to market weight in 18 months, and it used to take 3 or 4 years to get a calf to market weight, and now they do it in 18 months, all through genetic manipulation, and much, much worse. So we've been on that trail for a long time. Tell you a little bit about the NeoLife difference in quality control. Not only do we source our ingredients in these sorts of places, we actually know where they come from. Okay? We actually go to those places and look and certify that they're things we want to use. If we're going to buy tomatoes, we're going to go visit the tomato people. Okay? If we're going to buy carrots, we go to visit the carrot people. I have a picture of Dr. Hooper sitting in a carrot field in Florida from years ago, where he went out to go to the carrot field. He wanted to not only see the carrots, because we were buying a lot of carrots, but he wanted to understand how they grew their carrots, what they grew it with, what was being grown around where those carrots are being grown. You fly in these, airplanes that spray pesticides and herbicides over there. If the wind's coming this way, it's going to end up on there. So things like that. Early on, that was what we did. Now we actually specified genetics. We actually set it up for a specific gene pool. So for the type of carrots we get are the type of tomatoes are those that are genetically natural. We know that because we specify that gene sequence, and then when it comes in, we check to make sure it's that gene sequence. So not easy to do. Most companies that don't do it, as far as I can tell. Because a tomato is a tomato is a tomato, right? But not for us. There's a tomato, and then there's things that look like tomatoes, maybe tomatoes, but if it looks like a tomato and smells like a tomato and quacks like a tomato, it may not be a tomato. Oh, look at there. He's saving my life. Louis said, you should take a handful up there. Because he's been speaking for hours in the dry climate, I can tell. Thank you, Louis. Really good. So this is an example. I say farm to table. Obviously, we don't get our fish at the farm. We get them out of the water, out of the ocean. So this is just an example, but every one of these whole food ingredients has a source, and we go to the source and track it. So farm to table. Our goal is products you can trust. So everything that goes into every NeoLife product must meet stringent quality control. So every supplier, if you're selling us carrots, you have to qualify. We don't go to you and say, can we buy your carrots? you might come to us and say, I'd like to sell some, and we say, okay, good. All you got to do is qualify. What's the sequence to your genetic stock? Where do you grow these things? What's your history like? Show us your harvest feature. What's your protocols? What is the the analytical data for the materials you produce? And only after they comply with this rather strict gauntlet do they eventually end up getting in as approved as a supplier. Excuse me. Then again, just because you're a supplier doesn't mean you get an automatic pass the next time. So every ingredient from every supplier is checked and affirmed every time. Just because we've been buying carrots from you for 30 years does not mean that the next batch is going to slip in without being tested. Okay? No, it's not the way it works. Every supplier, every ingredient, every time passes the same criteria. So you're qualified and then you're requalified. So when we start, we carefully select farm fields. Again, in this particular case, we like to know where things are grown, what they're grown from, what the environment's like, what's the history of that area. You know, if you're downstream of Chernobyl, you're probably not going to get into our list here. Then we check for this, where they're grown, we check for the nutrient quality, the content of the nutrients. We have very stringent standards. The crops are continually analyzed during the growing process. If you think about it, the crop is grown, so we know what's being planted, what's growing, check, check, check. It's harvested, check. Then it moves into the distribution system, so it leaves the farm and goes to the extraction place, check. We put it in before we start a extraction process. We check it again. On the back side of the extraction, we check it again. Only then is it released to become a raw material. Remember, we started with carrots, and now we have a raw material, carotenoids. As it enters the system, it's checked again. All of these steps now, it's going into quarantine while it's checked. And each step along the way, it's checked. So if you think of carotenoid complex, the source material, the carrots are checked. The end product concentrate, the carrot oleo resin, which is where the carotenoids are, is checked. Then it goes into the manufacturing system where all of these things are blended together. It's checked. As it comes out of that, it's checked again. Then it goes to the encapsulation facility where it's quarantined before it's and then it's blended together, and before it's put in the capsule, it's checked again. And then after it's put in the capsule, it's checked again. And then when it's sent to our place, to our factory for packaging or whatever, we check it again. Again, it's quarantined on the way in. We check it, put it in the bottle, spot check the bottles, check it again, and then finally before it's released to distribution, it is checked yet again. And then even after it's been into the marketplace and sold, we continue to check on what's going on with these batches, okay? Just because that's the data stream, right? We need to have all of that data. It makes for bulletproof products, by the way. So we get these purest extracts I was telling you about, right? State-of-the-art processing where we take, happens to be soybeans here where we're making a soy protein. This is a Keldol apparatus where we're analyzing the nitrogen content so that we can determine whether the right amount of nitrogen is there, which gives us an indication of the protein content. And then this is just part of the extraction process where everything moves through the system and ends up in the vats. Check, check, check. We re-verification and confirmation as it leaves that factory. It goes through this verification. In addition to checking for things like contaminants and things you don't want in there, we always re-verify that what we want in there is there as well. Okay. And then it goes into the manufacturing process. And like I say, we check it again. When it comes out, it goes into quality control. Before it's released to the sales field or released to distribution, it's checked again. And then it eventually ends up at your door. Now you can see this whole journey. We can see this whole journey. Okay. On the side of every bottle, in this case carotenoid complex, there's a batch number. Okay. And that batch number integrates all the way back. So we can see this batch was made in this facility at this time from these raw materials. Boom, 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 boom. So then if you take one of those raw materials, this raw material came through this process at this time from this extractor. Boom, 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 boom. So then we go in and look at and say, The starter material that they came in at this time from this grower in this field. So we can check it all the way back to where it came from. Okay? Why? Why not? You know? The result of all this is this is one of the most, to me, one of the most powerful things we can say about our products, and that is NeoLife products meet or exceed the quality control standards for purity, potency, and consistency for every major regulatory authority in the world. And that is not easy. Okay, the US FDA is one thing, okay, but the Japanese Ministry of Health, they've got different ideas. And even the Canadians have different ideas, and the Australians, and the Europeans, and the Mexicans. Yet we managed to satisfy all of them because our own standards already exceed their requirements. Okay, it's just the way we are. Now I want to end with this. You know, we talk a lot about breakfast packs. Really important thing. When you go to sleep at night, you're asleep, but your body's not. Your body's working hard. Okay. You're not aware of it because it says get out of the way, shoves you to the side and goes about cleaning up the mess you made, right? But it's regenerating things, it's rebuilding new molecules, you know, whether it's hormones or tissue or new cells or whatever it is, it's busy because it's only got a few hours of you being offline so that it can do this work. Every morning when you wake up in what's called nitrogen debt. You heard me mention nitrogen a while ago, being a component of protein. It's because one of the primary things that's used up while you're asleep are amino acids, because amino acids are the building blocks of all of the neurochemistry, all of the sort of hormones and things like that that are involved in your body, let alone the tissue that makes the structure. There's all these biochemicals that regulate the function. So when you wake up in the morning, you're in nitrogen debt. So the most important thing you can do is give your body back that nitrogen, which is protein. Okay? So the breakfast pack is important because it gives you protein, but protein alone is just protein. You need to arm your body with all the other things that it used up overnight. Okay? Because while it was busy working, it was using antioxidants. It was using lipids to build cell membranes as it regenerated itself. All of these things are going on. So when you wake up in the morning, the most important thing you can do is fuel yourself. Everything that I've told you about here in this last presentation is present in this product, this simple concept of a breakfast pack. Okay? All of those things, the carotenoids and the omega-3s and the lipids and sterols from creatine and the vitamins and minerals and all protein and amino acids and all of that stuff, right there. Very simple, just arm your body right out of the box. I like that because it makes me feel good going out the door. Okay, I go, okay, I've got a good start on the day. Most of my days, I go from there. Some days, you know, I'm just so busy or, you know, traveling or something like that halfway around the world that my routine gets upset. But as soon as I can get back to that routine, I do. So, you know, one of the most important things you can do for yourself and for other people is have them recognize that while they were asleep, their body has been working. And when they wake up, the first thing that should be on their mind is, how do I service my body? How do I take care of my body? Because once you've done that, then you can approach your day and plan to go full speed ahead. Okay? Thanks very much.